I'm Anil Kumar sharing with you an excellent example based on exponential growth. The question here is, a population of bacteria is found to remain constant for the first 3 days and then it starts to double every day for the next 20 days. Based on this, we have 3 questions. A. When will this population cross 1 million? If the bacteria population is 100 on the first day. Right? Question 3b is, if the bacteria population is 100 on the first day, find the population on the 10th day. And C is, if the bacteria population is 400 on the 5th day, find the population on the first day. Right? So in different ways, we have taken one situation and we'll try to analyze it. That's the whole idea. Now what is basically given to us that the population remains constant for first 2 days, right? And then it begins to grow. So let's begin with part B so that we can develop our equation. Part A is working in the reverse way. We'll have to take logarithms to find the duration required for bacteria to cross 1 million mark. And C and B are kind of related. So let's begin with part B and understand what the equation should be. So what we are given here is that if the bacteria population is 100 on the first day, find the population on the 10th day. The condition is that population remains constant for the first 3 days, right? So if it is 100 on the first day, second day also it is going to be 100, third day also it is going to be 100, right? So first 3 days it is constant. Then it starts to double every day for the next 20 days. Now it starts to double, so it becomes 200 and then it becomes 400 and then 800 and so on. So that is how the trend is. So this one for one is the day 1, day 2, this is number of days, right? So day 3, day 4, day 5 and so on. Well, C is answered right from there. If the bacteria population is 400 on 5th day, right, so it is 400 on the 5th day, find the population on the first day. First day it is 100. So for C, we know the answer is that first day it is 100, right? So that is the answer for C. Now let's try to figure out answer for B. If the bacteria population is 100 on the first day, as given here, find the population on the 10th day. Now you observe that it starts really doubling after 3 days, and therefore we could actually write this equation in exponential form. Doubling means times 2. So the number of bacteria could be written as 100, the initial amount. Doubling time is after 3 days, so it will be n number of days minus 3, right? So on the 4th day it becomes 2 times. Does it make sense to you? Since it did not double for the first 3 days, we'll have to take away minus 3. And that is how we get our equation. Now if you want to find for 3b what happens on the 10th day, that is to say if n equals to 10, in that case the number of bacteria will be equal to 100 times 2 to the power of 10 minus 3, which is 7. So which is 100 times 2 to the power of 7. So we can actually calculate using the calculator. So we get 100 times 2 to the power of 7, and that is equal to 12800. So 12800 is the number of bacteria on the 10th day, right? So that's our answer for part B. So we can write this as 12800, right? Now, let us see how to find solution for 3a, which is our major question. So let me take it on a fresh page. So our formula is n is equal to 100, the initial population, times 2 to the power of n minus 3, right? Now in this case, when will this population cross a million? We can this capital N can be now changed with 1 million, right? So which is 6 zeros equals to 100 times 2 to the power of n minus 3. We can divide by 100, so we get 1 million divided by 100 equals to 2 to the power of n minus 3, and that is, we can cut off. So we get how much? 1, 2, 3, 4 zeros, right? So 4 zeros equals to 2 to the power of n minus 3. Now the difficulty is how to solve such equations where we have exponents. The way to solve this is to take log on both sides, right? So to solve this equation, we need to take logarithms on both sides. Then we solve it, right? So let me show you the process. So we take log, so we get log of 10,000, 4 zeros, equals to log of 2 to the power of n minus 3. Now we can use the properties of logarithms, right? So this log of 10,000 basically is there are 1, 2, 3, 4 zeros. This is number 4, right? But anyway, we'll just keep it like this. We say log of 10,000 divided by, well, we'll divide it later. Let me show you one more step. Here we'll apply the power rule of logarithms. So we get n minus 3 times log of 2. Now to isolate n minus 3, we are going to divide both sides by log 2. So we get log of 10,000 divided by log 2, right? And that is n for us. And when you calculate this value, you can add 3 to get your answer. So from here we get n equals to 3 plus log of 10,000 over log of 2, right? So that is how we calculate. Now in this calculation, you normally know what log of 10,000 is, but in general, what you should do is like this. Log of 10,000, right? You have to divide this by log of 2. And whatever you get, add 3 to this, add 3 to it, so plus 3 will give us, it gives us 16.28. So n is more than 16, so we'll say n equals to 17. So on the 17th day, it is going to be more than 1 million, right? So that is how you get your answer. So I hope this process is clear. So especially when you need to find the exponent, you need to use the logarithms. Logarithms are inverse of exponents, and they help to find such answers. I hope that is absolutely clear. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.